Now, in this figure you observe a 3D model of a cone which will be having a circular base at the bottom and taper to the apex point or the vertex as you see here. Normally when we are drawing this projections, we are going to divide this into 12 equal parts. I will explain you all those things when I show you the come to the projections of pyramids. We will explain you much about this when you view or draw it in the projections. We will try to understand the projection of cone by taking simple problems. Let us consider a problem having a cone of base 80 mm diameter and height 100 mm lying with one of its generators on HP, and the axis appears here. Axis appears is important for us to draw the final view. Here axis appears to be inclined at 40 degree to VP. You have to draw all the views. Now let us see once again the 3D model, whatever we showed you earlier, the same 3D model. Let us observe and try to understand what is what. This is the base of the cone. I call it as a bottom face. Normally, to understand the concept, we are going to divide this into 12 equal parts, each making an angle of 30 degree with horizontal 30, 60, 90 like this. We are going to divide into number of parts. This is only a constructional method. We are going to do it. And this is the end generator which is tangential to the arc or the circle. And this is how it has been divided: A, B, C, D, E, F, G, H, I and J I have eliminated. Here I have gone with L, K, M. Now you can see the axis as well as the generators. These are the 12 generators you can observe. From each point you have got 12 generators, and these are the generators, end generators. This I can call it as an end generator, and this has to be kept laying on HP, that is on ground. So let us try to understand this is the 3D view, 2D models of this structure. Draw XY line, mark this vertical plane and horizontal plane to draw the front and top views respectively. Let us start with the initial position by drawing a circle of a radius 40 mm and that is diameter 80 mm. Draw a circle of 40 radius. Divide this circle into 12 equal parts as I said earlier. Mark the axis O01, then join all this, mark it first, A, B, C, D, F up to N. Draw the generators by a little bit thinner line. It is not a thick line, only let the baseline be a thick line and all these generators be much thinner than the baseline thickness. Only for the visibility point of view I have drawn it with little bit thickness, but you can minimize the thickness. And let us draw the elevation of this one by drawing the projectors to the front view. Mark the height of the axis equal to 100 mm. Mark the apex point along the axis or center point along the center. Join all this from the divided parts. Name it as usual, you will be observing it from the front side. A is seen, B, C, D, E, F, G are seen. All these are behind because observer will be standing over here. These things will be marked in bracket within the bracket. Now measure the slant height, the end height or length of the end generator. End generator is GO. This is the true length because it is horizontal here. From the projection points you have understood the concept of true length. This is in true length. Now measure this OG, place it on the ground like this. You make it lie, rotate this. It is rotated like this, made it to lie on the ground on XY line. Now to mark the point A, measure GA and OA, draw the arcs from the respective points, get the point A. Once A is got, mark it with thick line and reproduce all these lines on this in this view. Mark all the end points of the base. Now this is the front view in the second position. To get the top view of this one, project it from all these points from A to A, back to A to A. To get the corresponding points, draw the horizontal projector from L, MKL, KM, NH, A, O, G, O, BF, CE and D. I got all the points in the top view. Now to draw this, the observer will be standing at the top, will be viewing from the top here like this. You'll be seeing the base phase. Now I'm not talking as it was spoken in the earlier videos about the longest line. We don't have any longest line as such here. All are end generators. So I'm not going to mark this by thick line as it was done in the earlier cases. In the case of generators, first we are going to look into the base cone. As in the case of cone, we are going to look into the base. Now if base is away from XY line, if this angle makes more than 90 degree, we say it is away from XY line. If this angle is less than 90 degree, we say it is towards XY line. So since it is away from XY line, it is nearer to the observer. So you can see the complete base. So mark this base A, B, C, D, F, G, H to A by a thick line like this. Now you are going to draw a tangential line from O to this curve, the oval shaped curve. You're going to, for this one, you're going to draw the tangential line. Yes, this is the tangential line. It is not joined to any of the end points as usual. It is simply joined to tangentially to this from O. Similarly, you do it for the bottom side and mark the axis. This is the top view in the second position. Let us try to understand the third position. How to draw the third position where the axis, top view of the axis is inclined at 40 degree to VP. Draw an angle of 40 degree to XY line. That means it is inclined to VP. Now we have to reproduce the figure here, whatever you see it in the top view in the second position, to be reproduced or redrawn on this along this axis. Measure length OO1, the apparent view length, and plot it along the drawn line. OO1 is marked. Mark the other corresponding widths here which are perpendicular to the axis and redraw this. I can observe that LAD is marked perpendicular to the axis at O1. Then mark the other lines. Plot all the positions. Whatever you see here, the same geometrical shape is produced here. Join the generators, end generators, which are nothing but the tangential line to the base of the cone. Now let us try to draw the front view by drawing the projectors from the top view, the vertical projectors, get the corresponding points on the base like this by drawing the horizontal projectors. Yes, we have marked from A to A, like A, B, C, D, E, F, G, H, I, J, K up to A. Now comes the which face you can see it, which you cannot see it. As you will be standing here in front of this cone, the observer will be here. You can see the complete base. It can be viewed. We are not going to draw as it was done in other problems, like taking the longest line away from XY line. Here in this case, we are not calling it by longest line, we call it as by n generators. So therefore, you cannot use that concept. We'll go with the second point of marking the imaginary and invisible lines. So since this is seen completely, you mark the base completely with thick line. After that, draw the tangential line to this base circle with respect to O. Similarly, the other end. So you got the n generators. We are not speaking with respect to the longest line. You are going to draw a tangential line here. Draw the axis. This completes the top and front views of a given problem. Now let us take another problem where the cone has got a base diameter of 60 mm and axis 80 mm, which lies on HP with its axis inclined at 45 degree to HP and 30 degree to VP. 45 to HP and 30 to VP. So it is just said that axis is inclined, therefore we'll go with the locus of O. The concept is simple, as it is all other things, what all the things I explained you earlier, the same thing holds good. The radius is 30 mm. You're going to draw a circle, divide that into equal number of parts, say 12 numbers here in this case. A circle is drawn of radius 30 mm. You're going to divide this into 12 equal parts. Each part makes an angle of 30 degree, 30 here, 60 here, 90, like this. With respect to horizontal or vertical, you can calculate. You're going to draw the diagonals here across, mark all these things, all these 12 parts, you're marking it. Project this to the front view to get the elevation. Mark the height of the axis equal to 80 mm. Join the end generators as well as the intermediate generators, AO, BO, all these things. Name it. Now in this case, the base is inclined to HP. The base we have to make it inclined to HP here by an angle, axis inclined at an angle 45 degree to HP. Therefore, we are going to tilt the base by an angle 90 minus theta. 90 minus theta is nothing but the angle that is made by the axis. It's 45 degree. So 90 minus 45 is 45 degree. We are going to tilt this base, keeping this corner G on the XY line. So it is tilted like this. We are not marking the axis in the beginning itself. Base is tilted at an angle 45 degree, keeping G on the ground. Now get the point O by measuring this length GO, draw an arc, and AO, you cut this previously drawn arc, or you can mark it like this. Either way you can do it. You can draw the arc, get the position here, draw the axis, you can extend it, or anyway this line is perpendicular, axis is perpendicular here to the base. From here you have drawn a 90 degree line. Join all the end connectors, they are called as generators, and the intermediate, just name all these parts as it was named earlier. Just redrawn this figure here this figure has been redrawn here by tilting the base by an angle 45 degree, where automatically the axis makes an angle of 45 degree with respect to the xy line. With respect to xy line means with respect to HP. Now get the projectors down, draw the projectors downward to get the top view. Draw the horizontal projectors from the corresponding points. Locate the points on the circumference of the circle. So we have marked all the points all along the length of the circle or circumference of the circle. Now you will be observing from top. You are going to draw the tangential line. Since you are observing the top, you will not be able to see the base. Base is less than 90 degree. So this complete base cannot be seen by the observer. So what we are going to do is, you are going to join all these points by a thin dotted line. It's a simple procedure of drawing the thick line. So first we'll start with a dotted line. Mark all these things. Draw a tangential line. Draw another tangential line here. You'll get an idea that this much part of the circle could be seen, and whatever that is there inside this, the lower portion cannot be seen. Therefore, we are going to have this dotted line. So you're going to draw tangential line, get an idea that only this much part of the circle could be seen from top. When you observe from top, only this much portion. That's why we have drawn with a dotted line. Now mark that portion by thick line. The inside with thick dashes like this. This completes the second position in the top view. Second position in the top view. Now let us draw the third position, where the axis of the cone is inclined at 30 degree to VP. So here it is an apparent view. True length of the axis was taken equal to 80 mm. Therefore, you have to make use of that one also here. You draw a line at an angle of 30 degree to the XY line. Mark the true length O1 and O2. This is O1. I am keeping this apex towards VP and the base towards the observer. Draw an horizontal line parallel to VP or parallel to XY line, which is called as the locus of O. Measure this length O1O. With O1 as center, draw an arc to cut the locus of O. To cut this horizontal line, draw an arc of length equal to O1O. You're going to cut it like this. Now redraw this complete figure with respect to this axis. Observe one by one. The construction method you can understand. It's very clear. All measurements measured here, plotted here. Measured here, marked here. You can see the tangent complete. This figure has been completely redrawn here with respect to this axis. The angle made by this axis, as I said earlier in other problems, will be always greater, will be represented as beta. Now get the front view. To draw this, you have erected the projectors, vertical projectors upward. Draw the horizontal projectors in the front view. Join the corresponding points. A is coming from here, it meets here, A, then NB, like other points. Yes, you marked all the points all along the surface, along the circumference of the diminished circle. Now, as I said earlier, we will be standing in front here. you're observing here, the complete base could be seen. The base could be completely seen, therefore you're going to join this line in sequence from A to A. You can see the circle in full view. You're going to draw the base. Since base is away from XY line and the observer will be here, observer will be observing this base completely, therefore it is completely seen, you are marking it by thick line. Then draw the tangential line from O to this circle, a diminished circle. And lastly, you draw the axis of the cone, show it like this. And as I explained earlier, you can see that beta angle that is measured here will be more than 30 degree. This is the top and front views of a given problem. The problem says that a cone of 60 mm diameter and 80 mm long is resting on HP with the axis inclined at 45 degree to HP and 30 degree to VP, and this is the final output of top and front views. This is the top view and this is the front view. Thank you for watching the video. Kindly like it, comment and share it, subscribe it.